z-scores. So first off, and when you're defining, when you're interpreting a z-score, I want to make sure that interpretations of z-scores must include context, which I think we did a good job of explaining that last time, and comparison direction, location to the mean. Now, what do I mean by this part right here? Comparison direction location to the mean.
How many standard deviations is it above or below the mean?
Yes, so this is above, below the mean. And yes, and I guess, you know what, I missed that one. I'm going to put a, it must also include number of SDs. So, okay, so that's part of the answer. So, I mean, that's part of it. But in addition to stating how many standard deviations, you know, some people get a z-score of 2, and somebody will say, z-score of 2, that's 2 standard deviations. No, a z-score of 2 is not 2 standard deviations. All right, first off, where's the context? Like, what are we even talking about here? 2 standard deviations for what? And then secondly, they'll say things like 2 standard deviations from, so z equals 2, for example, 2 standards from the mean. They'll say this. Now, let's say, of course, I didn't give you context, right? But without taking into account context, does this give you direction?
No.
No. This has no direction. And as such, you will lose half credit just from not putting direction. By writing from the mean, you'll miss it. If you forget context, you lose half credit. All right. So if you forgot, if you didn't say the context of who we're talking about, the who and the what, and then you didn't tell me above or below, you already got a 0 on the problem. The correct answer, of course, here would be 2 standard deviations above. And of course, you might have, you know, you're going to have some sentences above the mean, dot, dot, dot. So you're going to have some stuff in the front, you're going to have some stuff in the back. But what I want to put out in the forefront here is that you say 2 standard deviations above the mean if the z-score is positive. You don't just say 2 standard deviations from the mean. You don't just say 2 standard deviations. You give me the direction and how far it is from the mean. When talking about a number line of z-scores, let's say this is the number line of z-scores, and we have 0, 1, 2, 3, 4, -1, -2, -3, -4. All right. If we have a number that is 0, a z-score of 0, this means that this is the mean. If we have a number that is saying that is greater than 0, this means, of course, above the mean. If we have a number that's more than 2 standard, z-score of greater than 2, this is a high outlier. And of course, the opposites are much the same. If we have a number that is negative, this is below the mean. And if we had a number that is less than 2 standard deviations, this would be a low outlier. Now we say, mean. So, well, we don't. So Anne brings up a good question. When I say high, so when I say this word high, doesn't mean extreme. Okay. When I say the word high, this is a reference into it is a value unusually high. All right. I'm not the other word I think adds might be more is she's thinking more about the extreme outlier. So there's a difference. So you can have a high outlier, you can have an extreme high outlier. So when I talked about the idea behind z equals 3, so I talked about the problem when we cross this 3 or less than -3, those values refer to extreme outliers. But in our definition, we're just going to define an outlier is an outlier with a z-score that is any value that is more than 2 standard deviations from the mean, meaning above or below. That's our definition. As long as we justify it as such, the z-score is greater than 2, that's an outlier, then it's considered an outlier. So 2.2 by our mathematical definition is an outlier, but you can't just say it's an outlier. You need to give me direction. You always need to give me direction. So if I told you this student scored a 50, that was an outlier. So wait a minute, did she do really well or really bad? If I said this student score of 50 on the final exam was an outlier, we don't know. Correct. We don't know. It turns out that the average for the exam was a 30. It was a really tough exam. When you go to colleges and you're gonna be like, I took a class and the average final exam score was a 30. So a score of 50 was an outlier, an extremely high, it was a high outlier. So you need to tell me the direction. In respect to the rest of the data, you need to tell me it's above the mean and an outlier. That would be something that would also be appropriate. Not only is it above the mean, but it's an outlier. So you need to have direction. You need to tell me where this data point is in relationship to the other values and in relationship to the average. Does that answer your question?
Yeah, you did. Thank you.
Okay. Let's do let's do a comparison problem or an example. Or sorry, before I do that, overall means, overall z-scores, or comparing z-scores. So it should be noted that z-scores further from 0 are more unusual, i.e. a z-score of -2 is more unusual than a z-score of 1.5. Because 2 is more z-scores away, is more standard deviations away from the mean. So when I say more unusual, now that doesn't mean one is unusual, but one is more unusual than the other. All right. The closer you get to 0, the more typical you are. So the further you're away from 0 in regards to your z-score, the less typical it means. Now, to go to that question, Anne, it's not. You must be careful. Context will, or I get what you're saying. Yes. So yeah. So what Anne is saying, actually, what she's saying is true. So when you're just trying to fill unusualness, it's just the absolute value for that z-score. But careful, context will determine if positive or negative z-scores are good. All right. So, sometimes it is not even good. Sometimes what somebody would consider good, somebody else would consider bad. Right? So if we're talking about heights, i.e. heights, if you have a z-score that's positive, is that good or bad? Is it good, bad, or it depends?
It depends on
Yeah.
like each person.
No. It does depend, but what does it depend on? What is it? Now, what would the majority of people say, though?
Would they say it's bad?
Most people would actually say a positive z-score is good.
Really?
Talls are good.
Because you got higher than the mean, or you got greater than the rest of the class if it's scores.
Well, we're talking about heights. So it means
you're taller.
You're taller than average. Now, I know Kayla, so she probably thinks it's the opposite. She's like bad. Positive z-scores are bad, right? She's like tall people, she thinks shorter. It's better to be short. maybe. There's no.
Really?
Well, I'm just saying. There's no wrong answer in that. There's no like definitive like tall people are good. I mean that's a point of view, right? There's a difference between a point of view and really defining what that is. Same thing goes with weight, right? For most people, most would say a lower is good, is better, but that does not mean that's what society says, right? And I want to say most say. I would like to say say change that word to society says good for a positive z-score here.
That's why I said it depends on people, because everyone's opinion is different.
Yeah, but you have to tell me that part. So you have to tell me that it's society or that tall is good. All right, that's what I'm trying to say. You can't leave open that unknown or that part right here. So like for example, if I talked about weights, and if you had a z-score less than 0, is that good or bad? Okay, you're saying bad because why?
Society says shorter than average is bad.
We're not talking about height. New problem.
If you weigh more, yeah. Wait.
No.
This is talking about less, so it's good.
Well, you say someone said bad, so I just want an explanation. There's no wrong answer. If you say bad or you say good, both answers are right, but both answers are right now, and just saying bad or good are wrong because they're incomplete. Bad because why? It means you are underweight. You're below average weight. But somebody else can go over here and say good because the average American is obese. So negative z-scores are good. So this would also be correct. All right. In America, in our society, negative z-scores for average weight is actually probably a good thing. Mostly because we are an obese society. We are typically not just overweight, but way overweight. So if you're below average, now if you are if you are an extremely low, that's very bad, right? So there's also context. There's also even worse, though, because z-scores less than -2 would still possibly be considered bad, because this is extremely underweight, right? Anorexic. I don't know how to spell anorexic. So just think about that. You got to think about the understanding of what the context is of the problem, right? Now, it's also in terms of what your life is, in terms of where you're comparing. If you're in a third world country, I would probably be where most people are underweight. Negative z-scores are always bad in that society. Back in like medieval times, positive z-scores were considered good, and the bigger the z-score, the more positive the z-score, the better. It was a status of wealth to be overweight. That's why kings and queens were especially kings, were very, very fat, because all they did was sit around and eat and drink, and that's all they did. They didn't really do much, and it was a status symbol to be overweight. And if you were underweight, negative z-score, then it was a sign of that you didn't have the money to feed yourselves and your children. So there's context is the point. But z-scores can be good. Positive z-scores can be good. Positive z-scores can be bad. That's what I'm saying. Okay. If you're a gymnast, are positive z-scores good?
No.
No, you want to be short. Being short as a gymnast is very good. If you're a basketball player, are positive z-scores good?
Yes.
Yeah, that means you're really tall, and for that purpose of that population, it's a good thing. But if I'm talking about 40-yard dash times, good z-scores are what? We're talking about like a 40-yard dash, a sprint, a race. Do you want to have a positive z-score or negative z-score? You want negative. You want to be below the average time. You want to be faster, because if you're talking about the time, you want to finish that race faster with a time less than the average person, which means you're really fast. If we're talking about weightlifting, then good z-scores are what? Positive or negative? You're lifting weights. Are positive in this case. The more weight you can lift, the more above the mean you are in terms of the weight you lift, the better. All right. Now, what the AP Stats exam should do is that it should be very clear in terms of the concept of what is good and what is bad. If that is the case, if it's something to interpretation and you think it's bad, you can say why. You can, as long as you explain that part. Now, usually there's like 95% of the people would probably say one way, and that's how the exam is stated up. And then you say the opposite, and we're like, wow. But we read the exams, we read those AP responses, and we go, you know what? There are some people who responded with the opposite, and if they gave a justification such as this, we'll give them full credit. That's how we get when we grade in the AP exams. So as long as you explain why, now don't go too far and be too definitive on certain things. Good. That's why when you say it's good, that's very definitive. We don't really give credit for definitive answers, because there is some interpretation that needs to be taken into effect. All right. Example. So we're going to talk about quiz scores. Are quiz scores, are positive z-scores good or bad? Should be universal here. Who? Good. All right. You want a positive z-score, okay? You want to be above the mean. I think we're all in agreement, and there is zero wiggle room for saying, well, a negative z-score could, no, it's not on a quiz. Now we're talking about an exam, a quiz, okay? Alrighty here. So Amy scored an 80 on her math quiz and an 85 on her ELA quiz. Which one did she do better on?
We don't know yet.
Good. First and foremost, we do not know. That's a very important understanding in the world of statistics. We do not know which one she did better on. And if you still believe an 85 is better than an 80 in the world of statistics, we can't, because now if this was the same math exam, if there was the same quiz, is an 85 better than 80? Yeah. But this is apples to oranges. These are two different populations. We have the population of math quizzes and ELA quizzes. They have two populations. There's your apples to oranges. I guess I could have done apples as red and oranges as orange, but you know. All right. The mean and standard deviations are stated below. Which quiz did Amy do better on? Now, if this is on the AP Stats exam, what do you think the answer is going to turn out to be? Nine times out of 10, 8 times out of 10? What do you think the answer is going to be before we even actually see the summary statistics? If you had to take an educated, test-taking guess, which one is going to be the right answer? Anybody? Which one do you think is going to be the right answer? The math, ELA, or the same? Well, if this is a test, I would bet my money that the math quiz is going to be the answer. Why? Because it means there's some type of interpretation to that's going to have to be on. ELA seems like the obvious answer. So why give that type of question if that's going to be the answer? So when this question is presented, you got to think, well, they're trying to tell me that the ELA quiz is better, but I know that I need to look at the z-scores. So that doesn't mean that it's going to be math, but most likely it is. So here's a table, and it's very similar to the table you see on your homework. So here's the mean, here's the standard deviation. We're going to talk about the math, and we'll talk about the ELA. And the math mean is a 70, and the ELA was a 72. So based on right here, which test was harder? Which test was harder?
ELA?
Math.
Okay.
Math was harder because the average was lower. They had a lower average score. Now, does that mean that Amy did better on the math exam?
No.
We don't know yet. The answer, that does not necessarily mean that. Now, if Amy got an 85 on both exams, if she got an 85 on both of the exams, then which exam would she have done better on? If she had gotten the same score on her math and ELA quiz, she got an 85 on her math and an 85 on her ELA. The average for the math was a 72. The average for ELA was going to be 72. What would she have done better on?
Math.
Math, okay. Now, the real reason is because of she's that's the same population, or it's the same score. You still have to do what we're about to do, but everybody in here should be able to feel comfortable saying, well, wait a minute, if it was the same score, then she would have done better on the one that everybody else did worse on. The standard deviation for the math exam is 6 points, and the standard deviation for ELA is 10 points. Now then we take it into the spread here. So now the ELA scores are kind of spread out. So in other words, this is a class that the average was a 72, but the scores are pretty big. So it wouldn't be unusual for a student to get a score of 92, 2 standard deviations above. It wouldn't have been unusual. And it would not have been unusual for a student to get a 52. A student got a score of a 90. Is that good? Well, it's above the mean. Is it amazing? No, because it's not a high outlier. All right. But on the math, 2 standard deviations above is an 82. Okay, but so if you got a 90 and 2 standard deviations, a 90 would be considered a high outlier now, if we had the same score. Okay, so if she had scored a 90 on both the exams, for example. All right, remember, and I didn't write this, but z equals x minus the mean over the standard deviation. And now we have to do that. So what we're going to do is we're going to find the z-score for the math exam. So they're all Amy's z-scores. So what is the z-score for her math exam? How do I find a z-score for her math exam? I wanted this to be short, but it looks like try to pull some teeth here to get some responses. Is it going to be?
Do 80 minus. Yeah. Huh?
Yeah, I was going to say is the z-score going to be positive or negative?
Positive.
Positive, yeah, because she's above the mean. Good. So it's 80 minus what?
70, which is the mean.
All over?
6.
The standard, yeah.
6, good. And that gives me about 1.67. Z-score for ELA.
-85 minus 72 over 10.
Which is? Oh, about 1.3.
Oh.
It's 13 divided by 10. All right. Yeah, we got to use, because some people, and that happens a lot, some people use the 70 for both of them and stuff like that. All right, so which one did she do better on?
ELA, because it's farther. I mean, it's closer to 0.
Got it backwards.
Oh, wait.
Oh, no.
1.67.
On
Because it's
math.
farther? Is it because it's farther from 0?
Yes, but no credit still. Yes, but not the way you said it.
She did better than the average.
No. Anybody else want to try to chime in? Why? Right here, if I gave this is what we consider half credit solution so far. We would consider this a half credit z-score.
Because it's above the mean?
We always need something that's called linking. We did this when we were comparing, remember when we were comparing means and standard deviations? When we were comparing distributions, it's the same thing. You have to have some linking comparison. Because what? Now there's multiple ways to write this. There's multiple.
Oh, because she had a higher z-score or a greater z-score than him.
So that's one answer. Because higher z-score. Perfect. That would give you full credit. Another way you can say it is because 1.67 is greater than 1.3. And more, I would say I would add z. But 1.67 is bigger than 1.3. And I know that seems obvious. I know that seems like, well, duh. But when you say it's greater, I don't know if you're talking about the z-scores or if you're talking about the 80 and 85s. So when Anna was saying because because it's higher, 85 is higher, but 85 is higher. So that doesn't match. You have to compare and link that z-score response. Okay? All right. Overall, comparing overall z-scores. These problems are much the same thing, but we're going to combine. So when I say overall, I mean the combined z-scores. All right. So now we're comparing multiple people. All right. So
Was that homework 11? Overall z-scores?
The overall one, yes.
Yeah, that one. That was the one we're talking about right now.
So in this example, Armani got an 80 on math and a 63 in ELA. Darwin got an 85 on math and a 52 on ELA. Who did better overall? So who did better in these overall between these two classes? Was it Armani or was it Darwin? Now, if you look at it, you know, who did better on math?
Darwin?
Darwin. Who did better on ELA?
Armani?
Yep. So then, therefore, the answer is we don't know yet. We need to look at the z-scores. All right. Now, in this example, positive is good in both cases, right? We're talking about quizzes and quizzes. So positive is good on both of them. So we're talking about the mean and the standard deviation for math and ELA. The average math score was an 82 with a standard deviation of 5. And the ELA, the average was a 67. It was a much harder exam. That's why the lower scores. And a standard deviation of 3. So when doing this problem, we need to separate and actually find the z-scores for Darwin and the z-scores for Armani separately. Okay, so the first thing we're going to do on this problem is to find the z-score of math for Armani. So what is Armani's z-score?
For math or EP?
For math. For Armani. How do I calculate it? Not the answer. I want the calculations.
82.
Over.
5.
Good. And that gives me negative 0.4. Armani did below the mean. Below average on math. I'm just going down my list of names and I just picked 2 names on the top. ELA? How did Armani do in ELA?
63 minus 67 over 3.
Which is negative 1.3. So Armani did below average on math and below average on ELA. All right. Does that mean that Darwin did better?
No.
No, we got to
We
check.
don't know.
Yeah. So let's find the z-score for Darwin's math score, which would be what? My head.
That's 85 negative 82 over 5.
Good. Which is 0.6.
Yeah.
So Darwin did better than average on his math. Does that mean he's going to be the better student? We don't know. Let's find his z-score for his ELA exam, which is...
85 negative.
You didn't get no 85. You didn't get 85 on ELA.
Oh, sorry. So 52,
52 minus
67
over
over 3.
3, which is negative 5. So Darwin bombed his ELA exam. He's negative 5. Is that good or bad?
Good.
Oh, no. It's bad. You got a z-score of negative 5, which means you're 5 standard deviations below. Not only did he do below the mean, but what does this also tell us about Darwin's ELA score?
It's an extremely low outlier.
Which means what in terms of his grade? On
He
that,
did really, really bad.
yeah, he did really bad. He got an F on that exam. Now on the other ones, they're probably not Fs, right? A negative 0.4 is probably like a C. If the average grade is like a C, then a negative 0.4 would be like a C minus. A negative 1.3 is like maybe a D plus C, D plus C minus. A z-score of 0.6, that's probably like a C plus to a B minus maybe. We don't know in terms of it. But an ELA score of 52 was an F. All right. Now, some people look at these scores and they're like, if we just added the 2 scores, I want to point this out, and there's some good homework questions about this. If we were to add the 2 scores, Armani's 2 scores added together give me 143. Okay? Darwin's 2 scores together give me, and actually this is a bad example, I guess on this case, give me a 137. If we were just to add the 2 scores together, is that a good way of just noting who did better? If we just added the 2 scores together? The answer would be no. Okay? There are some homework questions that this does happen with. There'll be like, these two, if you add these 2 students' scores together, their average score is an 85. And if you get above an 80, you're on the honor society. And the other person's, when they added the 2 scores, is not an 80. It's less than 80. All right. So that person does not get to be on honor society. However, if we take a closer look, the student whose actual scores were less than the 80 average, or taking the 2 scores together, actually turn out to be much better when we look at z-scores. And so it turns out that individual is actually better than the other individual, and therefore they should be arguing there's something bad about the system. All right, so now the z-score for overall here would be, now negative, they're both quizzes, so they're both, we're going to treat both of these as negative. Because negative is bad, we're going to keep it as negative. I want to point that out. So it's negative 0.4 plus negative 1.3, which is negative 1.7. So overall, Armani did 1.7 standard deviations below the mean between his 2 exams. We look at Darwin, though, overall, and his overall is 0.6 plus negative 5, which is negative 4.4. So who did better? Well, in this example, and I just threw the numbers, Armani did better. So Armani, now his overall z-score is still below average, which is not good in that sense, but I want to note that Armani did do better as his overall z-score is greater than Darwin. Okay, his overall z-score is better. Now, if we were talking about something where, like I said, about the running part, and this is an example, and let's say the second one, let's say that the second one was not a quiz, all right? Instead of an ELA exam, and this is one of the questions that happens that I'm gonna give to you. Instead of ELA, it might be like a race, all right? So instead of ELA, it's like a race. And so in that case, we would treat this z-score as being good. So if this was a race, and this is how many z-scores he had, that'd be good. And Darwin would be really good, because if he was negative 5 standard deviations below the mean for a race time, that would be really good. And instead of doing this, we would actually change this, therefore, to be positive 1.3 here, and we would change this to be positive 5 here, because then that would be a good thing. That would give me positive 0.9 here, and that would give me 5.6 here. And in that case, Darwin would have done better because its overall net z-score would be greater. So in that instance, if the context of the problem turns where negative is good, then when you combine them, you would change it to be positive if negative was good. But in this, so like I said, if this was a race, then in a race, negative is good. So when you try to combine them, you don't want to just do the raw values and add them together. You have to change it in terms of good. So you want to if it's negative and negative is good, then you want to count that as a positive contribution, as we call it. We call it a contribution for it. All right. That's what I have for you. Thank you, everybody. I wanted to end it a little early, but I think there was some really good participation in here in terms of clarifying some of these questions. Homework is posted onto Google Classroom. Most of it is all about this comparing stuff. Go forth and complete. Thank you, and I'll see everybody tomorrow.